All right, so our next set of notes is operations with radicals. So adding, subtracting, multiplying, dividing is going to be its own separate set of notes. If you hear something in the background, it's Noelle. She's quite hyper this morning. So just ignore that. So the first thing we're going to do is add and subtract radicals. Your first step is always going to be to simplify all the radicals. You want them as simplified as they can be before you do any adding or subtracting. Okay. Once you have them simplified, you're going to identify the radicals with the same index and the same radicand. So they have to have the same index and the same radicand. Only these ones are the ones that we can combine like terms. And then for common radicals, you're going to add or subtract the coefficients and then keep the common radical. So just like with common denominators and fractions, once you have a common radical, it stays that radical. Right? So our first one, we have 2 square root of 27 minus 2 square root of 12. So we need to simplify 27 and 12. So for 27, we can use 9, so the square root of 9 times the square root of 3. And then for 12, we can use the square root of 4 times the square root of 3 to simplify 12. So the square root of 9 is 3. So we have 2 times 3 times the square root of 3 minus 2, and then the square root of 4 is 2 times 2 square root of 3. And then multiply the coefficients. So 2 times 3 is 6. So we have 6 square root of 3 minus 4 square root of 3. So then 6 minus 4 is going to be our next step because, fix this, we now have the square root of 3 as our radicand. That's the same. So now that they're both the square root of 3, we can just follow the operation with the coefficients. So 6 minus 4 is 2. So we have 2 square root of 3. And that is the final answer for this one. All right, so moving on. So we have 3 times the cube root of 54 minus 2 times the cube root of 2 plus 7 times the cube root of negative 16. All right, so let's just start with simplifying the radicals if we can. So we can definitely simplify the cube root of 54 because we can simplify that to the cube root of 27 times the cube root of 2, right? And then minus 2, and then the cube root of 2 is as simplified as that gets. So we're just going to leave this as the cube root of 2 plus 7. And we can simplify the cube root of negative 16 because we can make it the cube root of negative 8 times the cube root of 2. All right. So let's go back through and simplify more of what we can. So the cube root of 27 is 3. So we have 3 times the cube root of 2 minus 2 cube root of 2. And then the cube root of negative 8 is negative 2. So we have 7 times negative 2 times the cube root of 2. So now our next step is to multiply what we can. So 3 times 3 is 9. So we have 9 cube root of 2 minus 2 cube root of 2. And then 7 times negative 2 is negative 14. So we have minus 14 cube root of 2. And now it's just, we have the cube root of 2 in every single term. So now we're going to follow the operations with the coefficients. So we have 9 minus 2. So we're at 7, and then 7 minus 14 is negative 7. So we have negative 7 cube root of 2. And that's our final answer for number 2. All right, so for number 3, we have 10 times the square root of 28 plus the cube root of negative 56 minus 4 times the square root of 175. So we're going to simplify what we can. So we have 10, and then to simplify the square root of 28, we can use 4 and 7. So we have times the square root of 4 times the square root of 7. And then for 56, for the cube root of negative 56, we can do 8 and 7. So we have the cube root of negative 8 times the cube root of 7. And then, sorry, we have the square root of 175 that we have to simplify. So the factor of 175 that has a square root is 25. So we have 4 times the square root of 25 times the square root of 7. So let's go through and simplify our radicals. So the square root of 4 is 2. So we have 10 times 2 times the square root of 7. And then the cube root of negative 8 is negative 2. So we have negative 2 times the cube root of 7. Then minus 4. And then the square root of 25 is 5. So times 5, square root of 7. And then we're going to go through and multiply. So 10 times 2 is 20. So we have 20 square root of 7 minus 2 cube root of 7. And then 5 times 4 is 20. So minus 20 square root of 7. And I just realized I wrote a 3 in here instead of a 7. All right. Now, yes, there is a radical 7 in each of these terms. However, this one is the cube root of 7, and these two are the square roots. So the cube root of 7 we cannot combine with the square roots of 7. So we're just going to focus on 20 square root of 7 and negative 20 square root of 7. And we have 20 minus 20, which is 0. So we have those go away. 20 square root of 7 minus 20 square root of 7 is 0. So the only thing we're left with as an answer is negative 2 cube root of 7. And that's it. It's our final answer for number 3. All right, so for 4, we have to simplify both of these first. But if you look, this second term is already as simplified as it gets. So we're basically going to focus on the square root of 98 x to the 4th y squared. All right, so remember our index is 2 if it's square root. So the factors of 40 or 98 that have a square root are 49 times 2. And then x to the 4th and y squared, the exponents are already multiples of 2. So we're going to leave them as x to the 4th and y squared. So now just go left to right. So the square root of 49 is 7. 2 does not have a whole number square root, so that's going to stay. And then 4 divided by 2 is 2, so we have an x squared out here. 2 divided by 2 is 1, so this is y to the first power. So the only thing left is the square root of 2. And then just bring down this minus 3 x squared y square root of 2. Now, for this one, we have to make sure every variable has the same exponent in each term. So we have x squared and x squared, y to the first, square root of 2, square root of 2. So because they have all of the same exponents and variables and radicals, we can follow the operation with the exponents or coefficients. So we have 7 minus 3. So we have 4 x squared y square root of 2. And this is our final answer for number 4. All right, so we've been kind of using the multiplying rule just in reverse. When we simplify the square root, we split it into 2 radical signs. To multiply radicals, you do the backwards effect of that. So if you're multiplying 2 radicals, then you multiply what's underneath each radical sign, and then that's your answer. All right. And I realize there's not an O in that, so we'll just go with it. Then once you multiply, you're going to simplify the radical that you have. So multiply first, then simplify. So we have the square root of 27 times 5. So 27 times 5, I'm just going to do over here, it's 135. So we have the square root of 135. Now, we need the factors of 135 so that we know which one has the square root that we can use to simplify this. All right, and the largest is 9. So this is going to be the square root of 9 times the square root of 15. So then the square root of 9 is 3. And then this one we are going to put the plus or minus in front of. And so it's plus or minus 3 square root of 15. All right, so we have 3 square root of 10 times negative 2 square root of 18. So you're going to multiply the coefficients together. So 3 times negative 2. And then you're going to multiply what's underneath the radical sign. So 10 times 18. So 3 times negative 2 is negative 6. 10 times 18 is 180. And now we're going to simplify 180. And the factors of 180, where one has a square root, are 5 and 36. It's really bad 6. So this becomes negative 6 times the square root of 36 times the square root of 5. So the square root of 36 is 6. So we have negative 6 times 6 times the square root of 5. So negative 6 times 6 is negative 36 square root of 5. And there we go. All right, so for number 7, we have 2 times the cube root of 9 times 5 cube root of negative 24. So same thing, we're going to multiply 2 times 5. Then under the cube root, we're going to multiply 9 times negative 24. So 2 times 5 is 10. And then we have the cube root of 9 times negative 24. Oops. Negative 216. Oh, well, this one's going to work out quite nice. All right, so the reason I said this one's going to work out quite nice is because 216 is a perfect cube. So that means it has a whole number cube root itself, and that is 6. So we have 10, but because this is negative 216, it's negative 6. So 10 times negative 6 is negative 60. And that's our final answer for number 7. All right, to the next one. So we have negative 3 times the 4th root of 64 times negative 1. And remember, it's just if it's just a negative sign, it's negative 1. So negative 1 4th root of 8. So we have negative 3 times negative 1 times the 4th root of 64 times 8. All right. So 64 times 8 is 512. And then negative 3 times negative 1 is 3. So we have 3 times the 4th root of 512. And now this is the fun part, because 512, we need the factors of, and find the one with the largest cube root, or no, 4th root, which is actually 64 and 8. So we're actually going to erase this step because it's a pointless step, because we're just going to rewrite this again in a different way. So we have 3, and then the 4th root of 64 is 4. No. Hold on a second. cube root of 64 is 4. I'm stumped as to which pair that we need to use. All right, so let's go back to 3 times the 4th root of 512. And then I think we're going to have to use 16 and 32. So if 3 times the 4th root of 16 times the 4th root of 32, I can't seem to find anything larger that'll simplify further. So the 4th root of 16 is 2, so we have 3 times 2 times the 4th root of 32, and I just figured out what we're going to do. So then 3 times 2 is 6. However, we can simplify the 4th root of 32 even further, because factors of 32 are 2 and 16. So we're going to make this 4 square root of 16 times the 4th root of 2, and then the 4th root of 16 is 2, so we have 6 times 2 times the 4th root of 2, so our final answer is 12, 4th root of 2, and that's the final answer there. One way we could have made that shorter, now that I realize what it is, 512 divided by 2 is 256, which has, so if we do this as 3 times the 4th root of 256 times the 4th root of 2, then the 4th root of 256 is 4, so it becomes 3 times 4 times the 4th root of 2, which will get you the 12, 4th root of 2. So you can do this either way if you don't recognize right away that there's a larger number that'll work. So you can break it down step by step, or you can use the bigger number. All right, number 9. So we have 6x to the 4th times 5 square root of 8x to the 5th. So remember there's a 1 here, so you can make this as 1 times 5, which is 5. And then under this radical sign, we have 6 times 8, which is 48. And then x to the 4th and x to the 5th is x to the 9th. So for the square root of 48, x to the 9th, we're going to break those down into their factors. So the factors of 48 that we can use are 16 times 3. And then because this is square root, we know that the index is 2. So the closest multiple of 2 to 9 is 8. So this becomes x to the 8th times x to the 1st. So go left to right. So the square root of 16 is 4. So 5 times 4. The 3 is going to stay because there isn't a square root of 3. And then 8 divided by 2 is 4. So we have an x to the 4th. And then that x to the 1st is going to stay. So we have 3x left under the radical sign. So then our last step is to do 5 times 4. So we have 20 x to the 4th square root of 3x. And then that's as simplified as that one gets. All right, so moving on to number 10. So we have the cube root of 54m to the 8th. times the cube root of 5m to the 4th. So we have the cube root, and then 54 times 5 is 270. And then m to the 8th and m to the 4th is m to the 12th. So now we need to break these down into factors. So the factors of 270, where one is going to have a cube root, is 27 and 10. So 27 times 10. And 12 is a multiple of 3, so that's going to stay m to the 12th. So the cube root of 27 is 3. The 10 does not have a cube root, so it's going to stay under the radical sign. And then 12 divided by 3 is 4. So we have m to the 4th power, and then the cube root of 10. So our final answer is 3 m to the 4th cube root of 10. Just rewriting it so it's a little bit neater. Not much, but it'll do. All right, so number 11, we have the square root of 10 times the quantity 5 square root of 5 minus 2 square root of 2. So this is just distributive property. So you're just going to distribute the square root of 10 into the parentheses. So the square root of 10 times 5 square root of 5 becomes 5 square root of 50. Sorry, Noelle just walked in front of the screen, so I couldn't see it for just a second. Minus, and then the square root of 10 times 2 square root of 2 is 2 square root of 20. All right, and so now we're going to simplify the square roots as much as we can. So the factors of 50 that simplify are 25 and 2. So this becomes 5 times the square root of 25 times the square root of 2 minus 2. And then the factors of 20 are 4 and 5. So the square root of 4 times the square root of 5. So the square root of 25 is 5. So we have 5 times 5 square root of 2 minus 2. And then the square root of 4 is 2. So times 2 square root of 5. 5 times 5 is 25. So we have 25 square root of 2. 2 times 2 is 4. So minus 4 square root of 5. So we don't have the same radicand, which means we can't combine these any further. So 25 square root of 2 minus 4 square root of 5 is going to be our final answer for number 11. All right, and moving on to number 12, we have 8 minus the square root of 10 times 3 minus the square root of 10. All right, so we have to do distributive property twice, or FOIL if you want to think of it like that. So we have 8 times 3, which is 24. And then 8 times the square root of, or the negative square root of 10. 8 is not under the radical sign, so you don't multiply it by the 10. It's just right. If it was almost the same as if we did 8 times x and just wrote 8x, you're going to write negative 8 square root of 10. And then you're going to do negative square root of 10 times 3. So we have minus 3 square root of 10. And then negative square root of 10 times negative square root of 10. So negative times negative is positive. And then we have the square root of 100. So we're going to simplify and combine like terms. So we have 24. And then we have negative 8 square root of 10 and negative 3 square root of 10. Which is negative 11 square root of 10. And then the square root of 100 can be simplified to just 10, so plus 10. So in this case, we have one more step to simplify because we have 24 plus 10. So we have 34 minus 11 square root of 10. And there's our final answer. Right. Number 13. We have 4 minus the square root of 5 squared. And this is something that consistently all year, so many of us have messed up. If it is squared outside a set of parentheses, you do not square each individual term. Squared means you are multiplying that set of parentheses by another set of that same parentheses. So it becomes 4 minus the square root of 5 times 4 minus the square root of 5. All right, so now you do distributive property twice. So 4 times 4 is 16. 4 times negative square root of 5 is negative 4 square root of 5. Negative square root of 5 times 4 is negative 4 square root of 5. And then negative square root of 5 times the negative square root of 5 is positive square root of 25. So we have 16. And then negative 4 square root of 5 and negative 4 square root of 5 is negative 8 square root of 5. And then the square root of 25 is 5. So we have plus 5. So 16 plus 5 is 21. So you have 21 minus 8 square root of 5. And then that's our final answer for this question. So remember, if you are squaring a set of parentheses, you do not square each term. You write 2 sets of parentheses and do the distributive property twice. All right, so 14, we have the square root of x minus the square root of 8 times the square root of x plus 2. So the square root of x times the square root of x is the square root of x squared. Square root of x times 2, so we have plus 2 square root of x. And then negative square root of 8 times the square root of x, so we have negative square root of 8x. And then negative 8 square root of 8 times 2 is negative 2 square root of 8. All right, and we're going to simplify what we can. So the square root of x squared, we've talked about this already this chapter in the last couple of weeks. So if you take the square root of a squared, they cancel. So this just is x. There's nothing else to simplify in this, so it's going to stay 2 square root of x. And now we can simplify the square root of 8. So this becomes the square root of 4 times the square root of 2x. We'll just leave the x underneath there. And then the same thing is going to happen over here. So we have 2 times the square root of 4 times the square root of 2. So the x plus 2 square root of x is going to stay the same. Those two aren't going to simplify any further. However, this does. So we have minus, and the square root of 4 is 2. So this becomes 2 square root of 2x. Then minus 2. And then we have the square root of 4, which is 2. So times 2 square root of 2. And one more step, and then this one's done. Because we can multiply this 2 times 2. So we have x plus 2 square root of x minus 2 square root of 2x minus 4 square root of 2. Now if you look, we have a lot of combinations of 2 and x, but none of them are exactly the same. Like we have the square root of x, we have the square root of 2x, and we have the square root of 2. But it's not all consistent, so this is the final answer for this problem. All right, so we have one more question, and it's asking us to find the area of this rectangle based on the fact that one side is 4 minus the square root of 6, and the other is 7 square root of 6 plus 3. So to find the area of a rectangle, it's length times width, so we're multiplying these together. So our area equals 4 minus the square root of 6 times 7 square root of 6 plus the square root of 3. So now we're just distributing twice. We have 4 times 7 square root of 6. So because 4 is not under the square root, you multiply it by the 7. So we have 28 square root of 6. And then we have 4 times the square root of 3. So plus 4 square root of 3. Now this is where this gets fun. So we have negative square root of 6 times 7 square root of 6. So we have negative 7 square root of 36. And then the negative square root of 6 times the square root of 3. So we have minus the square root of 18. So we're going to simplify anything that we can. So 28 square root of 6 None of that simplifies any further, so it's going to stay 28 square root of 6. And then 4 square root of 3 also doesn't simplify any further. This is going to stay 4 square root of 3. This does simplify further because the square root of 36 is 6, so we can make this minus 7 times 6. And then minus, and then we can simplify the square root of 18 using 9 and 2. So we have the square root of 9 times the square root of 2. So the 28 square root of 6 plus 4 square root of 3, once again, don't change. But 7 times 6 is 42, so we have minus 42. And then the square root of 9 is 3, so we have minus 3 square root of 2. Now, none of these have the same radical. So the only thing that needs to happen with this problem is that it needs to be written in the correct order. And when the correct order is that the number without a radical needs to go first. So we have negative 42. And then I would go in descending order of the radicals. So the square root of 6 is going to be first, so plus 28 square root of 6. And then the square root of 3, so plus 4 square root of 3. And then the square root of 2, so minus 3 square root of 2. And there we go. And that's the last example. I know these notes were super long, but it covered a lot of stuff. So have a good day.